Hey there, algebra students. Mr. Lawrence here, and today we are going to be estimating ages using half-lives. Okay, now remember, a half-life is the amount of time it takes for a substance, for half the substance to decay. All right, so if I have half of it, well, if I have 100% of it, then after the half-life expires once, I have 50%. After it expires a second time, I have 25%, third time down to 12 and a half, etc., etc., etc. So let's see how to do this. It's actually really simple. I'm going to use this chart here, but I'm going to make it specific to my problem. These here refer to how many cycles have happened, how many cycles of half-lives. In other words, how many times half of it is decayed. Okay, so let's see. We have 18 and 3/4 percentage, something left. Half-life of 40 days. Well, first thing I'm going to do is make my table. I'm going to use 0 days, and that will be at 100%, right? Okay, well, what goes next? One cycle would be 40 days. How do I know? Because it has a half-life of 40 days, and that means there would be 50% left. Okay, and then I have 40 more days, so it'll be 80 days, and that's when 25% will be left. And I'm going to go until I sandwich this number. Like this percentage is not between 50 and 25, so I keep going. So I'm going to go another one. 40 more days will be 120 days. And then half of 25 is 12.5%. Now this number is somewhere in between those two, and so I'm ready to start to figure this out. Okay, what I'm going to do is I'm going to average 80 days and 120 days. So I'm going to take 80 plus 120 divided by 2, which is 100 days. Okay, so I'm at 100 days. Okay, and then I'm going to average these two numbers. So I'm going to do 25 plus 12.5 and divide by 2. Well, that's going to be 37.5 divided by 2. And half of 37.5 is going to be 18.75. Hey, look at that. It matches perfect, doesn't it? So that means the substance is 100 days old, approximately. I don't know about you, but I think that's pretty cool that I can figure that out based on the amount of whatever element it is we're testing for being left. So 18 and 3/4 is smack in the middle, and 100 is smack in the middle of 80 and 120, so it must be 100 days old. Okay, let's try one more here. Different type. This time the substance has a half-life of 620 years. So at 0 days, that's when there's 100% left. Okay, and then actually it should be years, but I guess it doesn't matter. 620 years, there's going to be 50% left. Okay, and I'm going all the way until I get 2 percentages on the other side of that. So I could go 25, and then I could go 12.5. I could go to 6.25. And then that would be 3, 1, 2, 5. And it looks like I am now sandwiching the 4.68%. So let me go in here and average these two. Okay. 6.25 plus 3 1/8 divided by 2. Oh, it comes out to be 4.6875. Okay, now let me come up here and write in 620 years, and 620 again would be 1240. And another 620 would be 1860. So how many years? And another 620 would be what? 2480. And another 620, 31, I think, on the nose. I'm just going to check my math on that. 2480 plus 620. Yeah, 3100 years old. So I know right now that the age of my substance is somewhere between 2,480 years old and 3,100 years old. If you think about it, this is the year 2013, and so this thing is older than that. So this is before, we started doing time in AD. All right, so I got 4.6875, which is pretty close to 4.68. Pretty darn close. So I'm going to average these. And when I do that, I'm going to get the average of 2480, 3100, and that's going to be 2,790 years. Now, which decimal is bigger? Which percent is bigger, the purple one or the yellow one? Well, the purple one, right? So there's a little bit more left here. So this number is a little bit lower, right? And so it can't be quite 2,790 days old. But I'll tell you, it's so close, it would be approximately. I would use that. I'd say the substance is approximately 2,790 years old. And there you go. So hopefully, seeing how I did that, where I make the little chart and then do the averages, you can make some good estimates for the approximate ages of things based on the percentage of the substance that is left. All right, if you need more help with that, please come in and see me. Mr. Lawrence signing off. Good night, everybody.